All right, here we have lesson six, application of the trigonometric ratios. So we're going to be looking at solving a triangle, which means solving all missing angles and the missing lengths. So this is going to require us to use the trigonometric ratios, Pythagorean theorem, and the angle sum property, depending on what we need to solve and when. So here in example 1, it is asking us to solve angle XYZ as illustrated by the capital letters in the corners where the angles are located, and to round the answer to the nearest tenth of a centimeter. So first I'm going to identify that I have two lengths that are located as the opposite and the adjacent, depending on if I'm looking at angle X or if I'm looking from angle Z. So I'm going to choose to solve for angle X. This is going to require me to use the tan ratio, which I know because I have the opposite value and the adjacent value. So I'm going to solve for tan of angle X is equal to opposite over adjacent. So therefore, tan X is equal to the opposite value, so right across from X is 10, over the value right beside, which is 6. To solve for an angle, you are using inverse tan. So in my calculator, I punch inverse tan, open bracket, 10 divided by 6, close the bracket. That solves for 59-degree angle. There. Now that I've solved for one angle, I have two in total because I have my 90-degree angle and 59. So I can now use the angle sum property to solve for angle Z. So angle Z is equal to 180 minus the 90 degrees minus the 59 degrees to give us a total of 31 degrees. Now, I could have started with angle Z and still use the tangent ratio to have opposite over adjacent. It just would have been 6 over 10. And then I could have also used the sum property, angle property sum, to then solve for it. Either way would have gotten you the same answer. And finally, now I need to solve for the third side. So this would be side Y. And to do so, I'm going to use the Pythagorean theorem. So a squared plus b squared is equal to c squared. And in this case, I am solving for the value of c, because c is your longest length, also known as your hypotenuse. So in this case, I'm going to use 6 squared plus 10 squared to give me c squared. 136 is equal to c squared. Now to solve for just the value of c, I need to take the square root of 136. So the value of c is equal to 11.6, and it's measured in centimeters, so I'm sure to include my units. And I have now solved for all three angles and all three sides. Looking at example 2, we have a right angle triangle with one side and acute angle on the other. Solve this triangle, so all three angles, all three sides, with our answers to the nearest tenth of a centimeter where necessary. So in this triangle, we are given 25 degrees, we're given one acute, and the 90. So I'm going to start with the angle sum property to solve for angle D. So angle D is equal to 180 minus 90 minus the 25 degrees that was given, to leave a remainder of 65 degrees for angle D. All three angles are now solved for, and with that information, I'm going to use it to solve for this side here, which would be side E. So I am given one angle, and I have the hypotenuse, and I want to solve for the opposite. So I think which one requires hypotenuse and opposite, and that would be sine. So I use sine is equal to opposite divided by the hypotenuse. In this case, I have sine of 25 because 25 degrees was given in the triangle is equal to, I don't know my value, so I'm going to call that x. I'm going to change that here. Divided by the hypotenuse, which is 5 centimeters. Now I want to isolate x. I want to get x by itself on the side of the equation. So to do so, I recognize this is division. The opposite division is multiplication. So I'm going to multiply by 5 on both sides. So 5 cancels out to be left with x. 5 multiplied by sine 25 gives us a value of 2.1 to equal x, and it's measured in centimeters. So this length here is now 2.1. I'm left with one remaining side, so I can use Pythagorean theorem to solve for that remaining side. So I have a squared plus b squared is equal to c squared. I'm going to substitute the information that I know. So I have a squared, which is I'm going to solve for, plus 2.1 squared is equal to 5 squared. A squared plus 4.41 is equal to 25. I now want to get a by itself, so I'm going to bring the 4.41 to the other side, so that would require me to subtract 4.41 and subtract 4.41, so it cancels. A squared is equal to 20.59. To solve just for the value of a, I need to find the square root of 20.59 to meet a is equal to 4.53. And because I'm solving for a length, my answer is in centimeters. Here's a problem that we're going to use trigonometric ratios to solve. The question says, to irrigate crops, a farmer uses a boom sprayer pulled by a tractor. The nozzles are 50 centimeters apart, as is also labeled on the diagram, and spray at an angle of 70 degrees. So this angle is 70 degrees. To the nearest centimeter, how high should the sprayer be placed above the crops to ensure the crops are watered? So in this case, it's illustrated by letter H. So here we can recognize that if we're going to solve for the height, this is actually a right angle triangle. Now, if this space from here to here is 25 centimeters, that means this space here would be, 50 centimeters, that means this must be 25 centimeters. If this whole angle is 70, half of it would therefore be 35 degrees. Now, we can solve for the value of the height. Given that I want to solve for the height and I have one angle and I have a value opposite and I want to solve for the adjacent, I think which formula uses opposite and adjacent, and that would be the tan ratio. So tan theta is equal to opposite over adjacent. Tan of 35 degrees, as we solve for, is equal to the opposite value, which is 25 divided by h. Now, when you have your variable on the bottom, you simply swap. So my equation will now solve h is equal to 25 divided by the tan of 35. Punch that into your calculator. Your answer will be 36 centimeters is the height required to spray the top of the crop. That concludes lesson 6.